Welcome to Study Loop.
In number 42, we have a double pane window. So there's two pieces of glass that are 0.8 centimeters thick each, and in between it is 1 centimeter air gap, and the area of the window is 1.5 meters squared. One side of the window has a temperature of negative 10 degrees Celsius, and the other one has a side of 15 degrees Celsius. And we're asked to find what is the rate of heat conduction. So the rate of heat conduction is this, it's the heat per time. So I'm going to use this equation. The heat per time is the thermal conductivity constant, which just depends on what kind of material you have, times the area, the temperature difference, divided by, this is the thickness. So energy can't get bunched up in here. So whatever rate it goes through the glass, it needs to go the same rate through the air and the same rate through this glass. So this part of the equation is the same from both materials. And the problem tells you that this pane of glass is the same as this pane of glass. So to make this simpler, I'm going to think of it as, pane of glass, and then air. So now I can think of this as a piece of glass that's 1.6 centimeters, and then here's my air. So this was glass, this was air, and this was 1 centimeter, this thickness. So I've got this, and I've got this. And somewhere between here is the temperature change here. So that's going to be the key. I'm going to call that, the temperature there, T. So it's going from negative 10 to T, and then T to positive 15. So I'm just going to set this up. So I have the thermal conductivity, this side I'll do glass. For glass times the area of the glass, the change in temperature of the glass over the thickness of the glass is equal to the thermal conductivity of air times the area of the air, the change in temperature of the air over the thickness of the air. Well, these areas are the same. They're both 1.5 meters squared, but nothing else is the same. I'm going to start substituting my values here. And remember, I'm trying to find this in between temperature. So this is, I can look up on the table 14.3, the thermal conductivity for glass is 0.84. My temperature, I'm going to have this one go from that to that, so my T2 will be T. My T1 is negative 10. Excuse me. And then my thickness, it was two of those together, so that's 1.6 centimeters. I'm going to put that in meters, 0.016. And now this is going to be for the air side. I look up on that same table. The conductivity for air is 0.23. This temperature is going to be 15 is what it's going to end at. T is what it's going to start at. And here my thickness is 1 centimeter that I'm putting in meters. I can do this dividing, and that's going to give me 52.5 times T minus negative, so T plus 10. And over here, this is going to be 2.3 times 15 minus T. Got to remember to do my distributing here. So I get 52.5 T plus 525 equals 34.5 minus 2.3 T. I get my like terms together. I'm going to bring my T's over here. So I add, so I get 54.8 T. I'm bringing that over here, so I get negative 490.5. I divide both sides, and I get that T, that in between temperature, will be negative 8.95. So now I can do either side of this to find the rate, now that I know what that other t is. So I'm going to do the glass side. I'm going to erase this. So for the glass side, the rate that heat is being transferred would be K. I'm going to do the glass side, so 0.84. My change in temperature now, I know that's going to go from the negative 8.95 to negative 10, so minus negative 10. And my area is both panes of glass, 0.16. So I get my rate of heat transfer is 82.7. And that would be joules per second. Or I could call that a watt. So that was part A. And then part B, I'd ask, what would be the transfer rate for just one thick piece of glass? If I just had one piece of glass, that was 1.6 centimeters thick. So I'm going to do that down here below. So for one thick piece of glass, I know the K value for glass. My area is 1.5. Oh, I didn't show that up here. I did have to include the area here. I'm going to put it back here. So to get this value, I did have to multiply this up. It didn't cancel. I had it on both sides here, so I could cancel, but here I didn't, so I could not. So down here, sorry. Down here, my change in temperature, I'm just going to put it together. So it goes from negative 10 to positive 15. So that's a change of 25. And the thickness of glass is the 16, the 0.016 meters. So this time I get 1,969 joules per second. So just by adding that little centimeter of air in between, my window doesn't lose nearly as much heat from the house now. So they ask us to compare this. This is about 24 times that.